So graphing tangent and cotangent, the biggest thing is kind of just remembering what shape it's supposed to be. So just like I did with sine and cosine, the first thing I'm going to do is make a note that this is a positive tangent graph. So the 3 points that I plot on the branches should be increasing in this way. And remember, the formula for period is pi divided by b instead of 2 pi. So b is 1. So the period here is just pi. And we find an asymptote rather than dividing the period into 4 parts. So the asymptote is setting the expression inside of the tangent function equal to pi over 2, because that's where in the parent function for tangent x, that's where one of the asymptotes are. So if we add pi to this side, 2 pi over 2 plus pi over 2 is 3 pi over 2. So there's an asymptote at x equals 3 pi over 2. So I just have you find that as one of the things because that's a good starting point. So I'm going to draw that in. And then the next asymptote, either to the left or the right of this, is going to be pi units away. So you can either calculate that mathematically, 3 pi over 2 plus or minus pi, or you can take a note, pi is 2 units, so you can just say, okay, 2 units over to the right will be another asymptote, or 2 units to the left. But it works out mathematically too. So 3 pi over 2 plus 2 pi over 2 is 5 pi over 2, or if I subtract, I get pi over 2. So once you get that pattern, these are periodic functions. So you can draw in the rest of the asymptotes every pi units. So basically at all the pi over 2's. And then for the branches, it doesn't matter where you start. I'm just going to start in the middle here. Again, I'm drawing these 3 points, and the amplitude, there's not an amplitude, but the A value here is 1. So in the exact center of the 2 asymptotes, you plot your point on the midline. And then halfway between that center point and an asymptote, so this would be at pi over 4, you reach up to that A value, which is 1. And then halfway between the middle point and the asymptote, you reach -1. And then you draw your branches. It's concave down to the left, concave up to the right. And then you just copy this shape because this is a periodic function. Copy the shape into each section enough to fill the window. And then once we get the thing graphed, or even before we get it graphed, you could also figure out domain. So might as well finish graphing while I'm doing this. When I run out of window, I just sort of extend it up a little bit. Last full branch here. And a little half branch goes up, and then I'll just make it go down a little bit. Okay, for the domain, now the domain is kind of like secant and cosecant. It's sort of the same formula every time. Pick an asymptote and add to that the distance between asymptotes. But for tangent, it's even easier because you can say pick your answer for asymptote. So all reals, x is not equal to 3 pi over 2. I just use that one because that's what I have written on my paper. I could use any of these asymptotes as a starting off point. And then add to that the period, because it's the period that will get you to the next asymptote for the tangent graph every single time. That was not true for secant and cosecant. It was half the period that got you there, but here it's the period. So I would just say plus pi k. K is an integer, and I'm just using the shorthand for that. Okay, let's do another one. So again, the first thing I do is take note of the shape. This is a negative tangent graph, so it's actually going to look like cotangent. It's going to be decreasing. And the fact that it's 2 means these points that are normally at 1 and -1 will be at 2 and -2 above the midline. B is 1/2, so the period is pi divided by 1/2, so that's 2 pi. An asymptote is taking the entire expression underneath or inside of the tangent function and setting it equal to pi over 2 if this is tangent. So I'm going to multiply by 2. X minus pi is equal to pi. and then I'm going to add pi. So I know there's one asymptote at 2 pi, and I can sketch that in. And then the next asymptote would be adding or subtracting 2 pi to that. So there's another one at 4 pi, because remember the distance is the period between these two asymptotes. If I subtract 2 pi, there's another one at 0. And then I can see enough of the pattern to keep going. So negative 2 pi, negative 4 pi. So we're only going to get 1, 2, 3, 4 branches on this one because we've had a horizontal stretch. We could do domain too. Domain is just talking about these asymptotes. So it's all real numbers. X is not equal to. Pick any starting asymptote. You could pick 0 because it's there. These are just happening every 2 pi k. If I'm starting at 0, I don't usually write that. But you also could say 2 pi plus 2 pi k or negative 2 pi plus 2 pi k. It doesn't matter as long as the first thing you write is one of the asymptotes, mine's 0, and then you add 2 pi k because 2 pi is the period. And then when we graph, so in between two asymptotes is the center on the midline. And then remember, this is negative 2 tangent. So to the left, halfway between the midpoint and the asymptote to the left, we're going up 2. And to the right, we're going down 2. So this graph has a vertical dilation by a factor of 2. And it's got a horizontal dilation by a factor of 2 as well. Then you just copy the pattern now that you see how far the points are supposed to be spaced. And the concavity is the opposite of what it was. It's concave up on the left side. Now it's concave down on the right. Basically for these graphs, let me check this. Yeah, when the graph is going up, it's concave up. When it's going down, it's concave down. Same thing here. Up, down, concave down. Sometimes people get mixed up with the concavity, and you're not going to have to sketch these for your AP exam, but you will have to sketch them for my quizzes and tests, so you need to have the concavity done correctly. Okay, now we're on to cotangent. So I'm going to make a note. If it's a positive cotangent, it looks like this, what we just did, decreasing. The period is still pi divided by b. Pi divided by 1/4 is 4 pi. The asymptote is taking the expression inside of cotangent and setting it equal to 0. Cotangent is the easy one to solve because the parent function has one of the asymptotes at 0. So x equals 0. So that's easy. I can sketch that in. And then the domain would be, the next one would be 0 plus or minus 4 pi. So the domain is just all real numbers. X is not equal to 4 pi k, just because I don't need to write the 0. And then k is an element of the integer number system. So the next asymptote should be all the way out at 4 pi. And then the one on the left should be all the way out at negative 4 pi. And then we can plot our points. So find the center, which would be at 2 pi. Halfway between 0 and 2 pi would be pi, and then 3 pi. And because we have an a value of 3, when I plot the point to the left, it should be up at 3, and the point on the right should be down at negative 3. So we graph like that. And same thing here. Copying that same shape with the points spaced out the same way. So we only get 2 branches to fit in this section. All right, a negative cotangent graph. So negative cotangent looks like tangent because it's a reflection of the original cotangent graph. The period here is just pi because it's pi divided by 1. And if we set x plus pi over 2 equal to 0, because this is a cotangent graph, then we get an asymptote at negative pi over 2. All right, so I'm going to sketch that in. The next asymptote is plus or minus pi units away from that. So if I add pi, which is 2 boxes, I land at pi over 2. If I subtract pi, I'm at negative 3 pi over 2. So you can see there's asymptotes every 2 boxes again at all of the pi over 2's. I'm just going to fill those in. And I can do domain as well. It's all real numbers. X is not equal to, where did we start? Negative pi over 2. What are we adding? The period times k, where k is an integer. So that says start at negative pi over 2 and add any number of pi's, and you will land, or subtract, you will land on another asymptote. And then when it comes down to drawing the branches, this is negative cotangent. So I'm going to start in the middle here. It starts on the midline in the middle. Halfway between that point and the asymptote would be pi over 4. It's going to go up to 1 because that's the a value. Negative pi over 4, it's going to go to negative 1. Concave down when it opens down, concave up when it opens up. And I just copy that shape all the way through. When you get to the little half point, just indicate that it continues on, and then copy this on the negative side of the graph as well. Okay, so that finishes this graph. Negative cotangent looks just like tangent. All right, what if we have a little bit of everything? You can see we have a value for A, B, C, and D. Remember, with tangent, we're not looking at shifts or any of that. We're getting all of the shifts by plotting the asymptotes the correct distance apart. So begin by looking at the fact that it's positive tangent, so the points are going to go like this. The 1/4 affects the period. Pi divided by 1/4 is 4 pi. Finding the asymptote is taking the entire expression inside of tangent, so 1/4 times x minus 2 pi. And this is back to a tangent graph, so set the tangent equation equal to pi over 2. So one of the things you need to memorize is if it's tangent, set it equal to pi over 2. It's cotangent, set it equal to 0. Multiply by 4. X minus 2 pi equals 4 times pi over 2 is 2 pi. Add 2 pi. So we get a vertical asymptote at 4 pi. X equals 4 pi. The next asymptote will be plus or minus 4 pi units away from that. So we can't do 8 pi, that's off our grid, but we can go minus 4 pi to get us at 0. And another minus 4 pi will land us at negative 4 pi. And then we can also do the graph. Now here's one, we haven't had this yet. We have a midline here, plus 1. So just like we did for sine, cosine, secant, cosecant, you can sketch in a midline. You don't have to do that, but that does shift the graph up 1 unit. So normally when we go to plot our points, we say, okay, we're going to plot in the exact center, we're going to plot at 0, but really it's that we're plotting on the midline. That point would get shifted up 1. And then the halfway points that we're going to plot at pi and 3 pi, those should be 2 units above the midline and 2 units below. So on the left, it's 2 units below the midline. And on the right, it's 2 units above the midline. And then I try to make this concave up. It's kind of hard to get the concavity on these. Just missed that point again. Something like that. And then same thing here. On the midline at negative 2 pi, 2 units above at negative pi, and 2 units below the midline at negative 3 pi. And for the domain, it's all real numbers, but x is not equal to 0, 4 pi, 8 pi. I'm just going to write 4 pi k. So you can still use patterns for these, but you could also say 0 plus 4 pi k or 4 pi plus 4 pi k. Those are all equivalent. This last graph is cotangent. So positive cotangent means the points are going to go down like that. The period is pi divided by 1/2, so 2 pi. Set the expression 1/2 times x minus 4 pi equal to 0 because this is cotangent. So if you multiply by 2, x minus 4 pi is still 0, so x is 4 pi. So I'm going to draw in the first asymptote. The next asymptote is at 4 pi plus or minus 2 pi, because that's the period. So it can't go 6 pi, so I'm going to go backwards to 2 pi. And then you're plotting these every 2 pi. So another 2 pi would be 0, and negative 2 pi, and negative 4 pi. This graph has a midline of minus 2, so let's draw that in. And then when we go to draw our branches, they'll be around the midline. So if I start here between 0 and 2 pi, there's a point on the midline. Cotangent's A value is 1. So to the left, I'm going up 1. To the right, I'm going down 1. Okay, and then I copy that shape again. Again, when the graph is going up like that, concave up, concave down below the midline. And last section here. And domain, all reals, x is not equal to 0 plus 2 pi k, or 2 pi plus 2 pi k, or just 2 pi k. K is an integer. And yeah, that's the tangent graph and the cotangent graph. So a little bit more of a formula for these, I think, than sine and cosine there. I think there's less to think about for tangent and cotangent. So come see me in office hours if you need extra practice or have questions.